Hi students, Professor Gray here. I believe we left off on this slide last time because I had it in PowerPoint and it wouldn't let me have the pictures, but here we are again with some redox reactions, and the questions here ask us to identify the oxidizing and reducing agents in each of the following chemical equations. So in order to do this, we have to figure out who's being oxidized and who is being reduced. So just to remind ourselves, we had the handy dandy little oil rig thing here, which meant oxidation is loss, and it was loss of electrons. And then reduction is gain, so it was gain of electrons. So let's take a look at number one. So what we have to do is we have to take a look at what each element is doing on its own. Now, in order to do this, we're going to go ahead and say, okay, what is aluminum doing? And we're just going to look at one aluminum at a time. Now, aluminum is in its natural state there. It's as a solid, it's not in a compound. So what we say is the oxidation state, or for us, the charge on that one is 0. Now, what's happening to it? Well, we don't know if it's gaining electrons or losing electrons at this point. So we're going to put a space. So we're going to leave a space right here just in case we have to add electrons, and put the reaction arrow, and then we're going to put another aluminum over on this side. Now on the product side, that aluminum is part of a compound. It's Al2O3, and way back when we did ionic and covalent compounds, we said that with ionic compounds, you're going to have charges and you have to figure out what the charges are. And when we had the chart, we looked on the chart and said, okay, aluminum always does +3 when it's in an ionic compound, and this one is no different. So we're going to do +3 here, or 3+. Now, how do we go from a neutral charge to a +3? Do we add electrons to the aluminum with the neutral charge or the 0 oxidation number? Or do we give away electrons in order to go from 0 to +3? Well, in order to go from 0 to +3 to get more positive, you have to give away electrons. Now, this is going to seem kind of funny because a lot of students want to put plus electrons on this side, but that's not what we're going to do, because we're not adding electrons to Al with the oxidation state of 0. What we're doing is that we're taking this aluminum and we're turning it into aluminum +3. In order to get aluminum +3, you had to also give away 3 of your negative charges. And so how we write that is +3 electrons. So these 3 electrons right here are taking off. So what happens is the number was not reduced, it was increased, and so that means it's not reduction, so this is oxidation. Okay, and then we have to look at what happens in this reaction when we have the oxygen going from an oxygen in its normal state, which is as O2 gas. And remember, we're just going to look at one atom at a time. I know it happens as O2, but just one atom at a time here. And it's going to have that oxidation state of 0 because it's in its natural state. And what happens is something's going to happen to it in order to change it into the oxygen that's in that compound there. Now, the oxygen that's in that compound, if we think about ionic compounds, we know the oxygen always does -2. Now, how do you go from 0 to -2? Do you add electrons to yourself, those negative charges, to go from 0 to -2? Or do you get rid of your electrons to go from 0 to -2? Well, the answer is, in order to go from 0 to -2, you have to add 2 negative charges. So we would add 2 electrons. And also, the number was reduced. We went from 0 down to -2. So that should make sense that this is reduction. When you add electrons or you add negative charges to yourself, you are reduced. That process is called reduction. Now, the question asks us to identify the oxidizing and reducing agents. Now, before we said this is kind of weird because it sounds opposite of what we think it should be. But what happens is whoever's being oxidized, which is the aluminum right there, is giving away electrons. So it itself, the aluminum itself, is oxidized, but because it's giving away electrons, it's causing somebody else to be reduced. So aluminum is the reducing agent. And that means that oxygen is the what? The oxidizing agent. Now, oxygen itself is being reduced. Its oxidation number, or for us, we can just say the charge, is going from 0 to -2. You can see that that number is being reduced. It's going down. It's gaining electrons. And because it's taking somebody else's electrons, it is causing somebody else to be oxidized. It's causing somebody else to get rid of its electrons. So it is the oxidizing agent, even though it itself is being reduced. Now, if we look at how many times these simple reactions happen, this one and this one, what we'll find is that the number of electrons given away by these 4 aluminums is going to be exactly the same number of electrons taken on by these 6 oxygens. So if each single aluminum gives away 3 electrons and you have 4 aluminums, you would have 4 times 3 electrons, which equals 12 electrons being given up by those 4 aluminums. And you have 3 times 2 oxygens, so you'd have 6 oxygens. And those 6 oxygens are all taking on 2 electrons each. So that means that the oxygens are gaining 12 electrons. So those 4 aluminums give away 12 electrons, and the 6 oxygens gladly take those 12 electrons. And that's a redox reaction. The oxidation and the reduction happen together. Somebody has to be giving away their electrons in order for somebody else to steal them. Okay, so we're gonna look at number 2. So number 2 has iron, oxygen, and aluminum. Now, let's identify ones that are in their natural states. So we've got aluminum as a solid, and we've got iron as a solid there. And so we've got Al, 0 charge, iron, 0 charge. And then again, we have aluminum oxide here. And what we have is we have Al plus 3, and we have O minus 2. Obviously, we have 2 Al plus 3s and 3 O minus 2s. But again, in redox, we just look at each individual atom or ion. So over here, again, we have oxygens that are minus 2 because oxygens usually do minus 2. And if you got 3 of them, that's -6 altogether. So in order for those 2 irons to be +6 to balance out the -6 charge from the 3 oxygens, your irons have to be +3, okay? And yes, I know there are 2 of them, but again, in redox, we just look at one at a time, what's happening. Now notice that nothing happens to the oxygens. Oxygen goes from -2 to -2. So we're going to leave those ones out because they are not being reduced and they're not being oxidized. Okay, it's staying the same. Now let's look at what happens here. We're going to go from +3 to 0 there. So what you have is +3 going down to 0. So is that oxidation or reduction? It's reduction because the number is reduced. An iron +3 will have to gain 3 electrons to go to iron 0. Now, what's happening with the aluminum? Well, aluminum goes from Al0 to +3 there. So the number definitely is not being reduced, and we found that the iron was being reduced. So we know that that one is oxidation, okay? So oxidation is loss of electrons. So the aluminum right here lost how many electrons to go to +3? It must have lost 3 electrons, okay? So bye-bye 3 electrons. And what happened to those 3 electrons that the aluminum loses is it transfers them on over to the iron. And so that iron +3 grabs those 3 electrons and it goes from iron +3 to iron 0. And grabbing negative charges means that your number is going to be reduced. Okay. So if iron is reduced, then it is the what agent? It is the oxidizing agent. Because if it is stealing electrons from somebody else, it is reduced itself, but it's causing somebody else to be oxidized. Now, aluminum is giving away its electrons, and aluminum is oxidized. So if it itself is being oxidized, it is doing what to somebody else? It's reducing somebody else, so it is the reducing agent. Okay. So that was that slide, and next time we're going to go on to the mole.